Take a quick look around you. I bet, right now, you're not too far from a simple metal tube. It's in your car, your furniture, probably the very building you're in. But behind that everyday object, well, there's a whole world of incredible complexity and precision. So today, we're going to pull back that curtain.
So what does it really take to make a perfect metal tube? I mean, it sounds simple enough, right? But as you're about to see, the answer takes us on a journey through some of the toughest challenges in all of modern manufacturing.
And this is where it gets really interesting. The massive gap between what we think a tube is and what it actually has to be. To us, it's just a hollow cylinder. But for industries from aerospace to medicine, it's a component that demands microscopic precision, absolutely flawless welds, and total material purity. The list goes on and on. Okay, so to get to that level of perfection, manufacturers face some huge hurdles. And this isn't just about bending a piece of metal. Oh no, it's a battle against physics, chemistry, and even human error at every single step of the process.
The whole challenge starts before a single tube is even formed. First, you have to pick the perfect grade of stainless steel, which is this constant balancing act between strength and, say, corrosion resistance. Then you've got to find a reliable supplier, all while trying to dodge inconsistent quality or delays that could just completely derail your entire production line.
So once you have the material, you run straight into the tyranny of tolerances. A dimensional tolerance is basically the tiny, acceptable wiggle room in a tube size. And when I say tiny, I mean it. We're often talking about a fraction of the width of a human hair.
And this right here shows you exactly why those tolerances matter so much. A tiny deviation, something smaller than a grain of sand, might not sound like a big deal. But it could mean a fuel line in a car starts to leak, or a critical part in a medical device fails. The stakes are just incredibly high.
And it doesn't stop with dimensions. There's another crucial balancing act going on. The metal has to be both unbelievably strong and surprisingly flexible. It's a property called ductility. And if you get that balance wrong even by a little bit, the tube just cracks during the forming process. All that time, material, and money, gone.
The physical quest for perfection just keeps going. Manufacturers are fighting to maintain a perfectly uniform wall thickness from one end of the tube to the other. They have to create welds so clean they're practically invisible to guarantee the thing holds up. For industries like healthcare, they even have to polish the surfaces to a mirror finish. And they have to do all of this for thousands of different custom shapes and sizes. It's relentless.
So let's say you do it. You manage to make a seemingly perfect tube. How do you prove it? Well, quality control is a total nightmare. Advanced testing, like using X-rays, is super slow and really expensive. You have to guarantee zero contamination for medical or food-grade tubes. And on top of all that, you're trying to keep up with this constantly changing rulebook of industry standards.
So, when you add all these hurdles together, what do you get? A process that's often riddled with inconsistency, frustrating delays, and costs that just keep climbing. For decades, this was just how it was. The accepted reality of making a high-quality tube, but that is all starting to change.
And this is where things get really exciting. Enter the automated revolution. We're talking about artificial intelligence and robotics coming in and completely transforming this old-school industry from the ground up.
The biggest change is happening in quality control. See, the old way relied on human inspectors who, let's be honest, get tired and can be inconsistent no matter how good they are. The new way? It uses high-resolution cameras and AI that literally never blink. They analyze the production line in real time, which lets them shift from just reacting to errors to actually predicting them before they even happen.
So how does this all work? It's actually pretty simple when you break it down. Step 1. Cameras capture video of every single tube coming off the line. Step 2, an AI analyzes that video, spotting microscopic defects in milliseconds. And Step 3, if a defect is found, a robotic system instantly acts, pulling that flawed piece right off the line. It's this seamless, super fast loop of detection and correction.
And the impact is just staggering. AI isn't just spotting defects in the tubes, it's practically listening to the machinery itself. By analyzing all the sensor data, it can predict when a part is about to fail. This has led to a 15% reduction in unplanned downtime. Now, that number might not sound huge, but in the world of manufacturing, that is a massive gain in efficiency. This is the real payoff of building a smart factory. It's not just about one cool piece of tech. By catching flaws early, it slashes operating costs, often by millions. By making sure a perfect product gets to the customer every single time, it protects a company's reputation. And maybe most importantly,
It builds a production line that is constantly learning and optimizing itself. But you know what? AI-driven quality control is really just the beginning. We're just scratching the surface. The entire innovation pipeline for how we make tubes is being reimagined, and it's leading us toward building the pipes of tomorrow.
As we look ahead, this innovation pipeline is just packed with exciting new trends. We're seeing a big shift toward advanced composites that are lighter and greener. 3D printing is opening the door for rapid prototyping and levels of customization we've never seen before. And there's a huge focus on things like modular fabrication and sustainable materials, like recycled steel, that are making the whole process faster and way more eco-friendly.
So, why does all of this matter, right? Why pour so much energy into perfecting something as simple as a tube? Well, because it was never just about the tube itself. It's about what we can build with it.
And this quote, from someone working right there in the industry, really gets to the heart of it all. This drive for new technology, it comes from a very human desire to solve problems, to work smarter, and to improve things proactively. It's all about empowering people to make better, faster decisions. And that really brings us to our final thought. This whole journey into the unseen world of a simple tube, it's really a preview of a much, much larger manufacturing revolution. It proves that with the right tech, we can hit a level of precision and efficiency that we once thought was impossible. So the question is, if AI can perfect the humble pipe, what can't we build next?